Okay, this is pretest 3, uh, questions 9 and 10. Question number 9 here asks to solve by the complete the square method. And in an earlier video, we demonstrated complete the square and did a set of bullet points for it. The first bullet point for the complete the square process, which is typically used with a quadratic equation, is to force a to be 1, right? And by a, we mean the coefficient of the square term. And you do that by dividing all terms by a. And so what that's going to look like here is we're going to divide every term, even the 0 side, by 3. And so what that sets us up for, right, is it gives us an x squared minus a 2x minus a 1/3 equals a 0, of course. What that sets us up for is when we factor, if we just skip ahead here for a minute, when we factor, it's going to be very easy to factor because our lead term is a 1x squared. It's simply going to factor into 1x and 1x. So it's sort of forced factoring is what it is, to complete the square method. Now, the second bullet point that we made available earlier is to remove c to the 0 side. And we also made a point to leave a hole, right? Leave a hole. And all that means is you write down the x squared, you write the minus 2x. We're going to move, in this case, the minus 1/3. We're going to move it from the left-hand member to the right-hand member, additive inverse. So that's a plus 1/3. And we leave a space right here. And we leave a space because of the forced factoring we're doing, there's going to be a necessity that another term gets added on, right? Following bullet point is to factor, right? To actually make your two sets of parentheses, which we've sort of already done over there. And you do it by splitting B, right? And so right here's your B minus 2. We're just going to split that in 2, and we're going to have minus 1 and minus 1. Whatever number your B value is, you take half of it. And so in this case, it's minus 1 and minus 1. And then you square back, we said. And that's why we left the hole. Square back, fill the hole, right? Fill the hole. So the idea is that multiplying these two binomials together, you're going to get the x squared you planned. You are going to get, by outer pair and inner pair, you're going to get the minus 2x you planned. But you're also going to cause a consequence of the way you're forcing this squaring. You're also going to cause an addition of a 1 in this case. Because when you multiply the last term times the last term, you get a plus 1. And you have to add that to both sides, right? So the next bullet point in the process also said both sides, all right? And what is 1/3 right here plus 1? I hope everybody understands that's 4/3. Make sure you understand why that's 4/3, all right? Then, next bullet point said to write it as a square, right? So since you've got the same binomial being multiplied times itself right there, right? That's a square. That's where that name is coming from. All right, like that. And now you finish by doing a square root. The opposite of squaring is to do the square root. And so we got x minus 1. Remember, when you do that square root, you must consider plus and minus values. Now, the square root of 4 is a plain old 2 over rad 3. The square root of 3 stays in the square root. Square root of 4 is the 2. Make sure you're understanding that manipulation. And finally, bring the 1 over, And typically you put it in front of the plus minus. You wouldn't have to. You could put it after the fraction if you wanted to, but typically it would get loaded in front. And so our final answer, 1 plus minus 2 over rad 3. Now, if you want to, you can rationalize this denominator. Might be better to multiply top and bottom of that ratio by square root of 3. And so another way to look at these two answers, 1 minus 2 rad 3 over 3, and the other answer, 1 plus 2 rad 3 over 3. And again, when you enter these into WebAssign, you have to enter each of those answers separately. So it would be looking something like this. The order doesn't matter, but it would be something like that entered into WebAssign and using the MatPad that shows up there to maybe do the fractions and some of those things that you might find difficult. Okay, so that's the complete the square process again. Force A to be 1, remove the constant to the 0 side, factor by splitting the B, square back to both sides, and then write it as a square, and then finish by square root. So that's the complete the square process. I'm going to move on to this number 10, and it's an equation containing ratios, containing rational expressions, and those rational expressions have denominators with variables in them. And so, as we've talked about, see the structure, make a little note to yourself. X cannot be 0. If X is 0, this term right here becomes undefined. All right, blows it out of the water. And X cannot be 3. All right, so further, if we actually solve this and get one of those answers, we're going to know right away that that can't be an answer. All right. Now, beyond that, probably what I would do here is keep the rational expressions together on one side of the equation and move the constant out to the other side, like that. All right, just so I have those two together. Now, to add or subtract fractions, you need a common denominator. We're subtracting here. We have a denominator of x. We have a denominator of x minus 3. Your common denominator is going to be x times x minus 3. Right? Now, to obtain the x times x minus 3, on the left-hand ratio, we're going to multiply top and bottom. Make sure you get this by x minus 3. And that's going to give us 10x minus 30. Clear? And the right-hand ratio, going to multiply top and bottom by x. And so we're going to subtract 12x. Now I left the denominator in the multiplied in the factored form. I didn't actually do the distributive property. The reason I'm doing that is I'm checking to see if when I do the combination of the numerators, if somehow I have a chance of getting some factoring to some canceling rather to happen somehow. I got minus 2x minus 30. They are both negative. They are both even. Could factor out a 2, but it really isn't going to pay any dividends because if you factor out a 2, you're going to have a negative 2. You're going to have x plus 15. There won't be any canceling there. Okay, so up here, going to rewrite this thing as minus 2x minus 30 over x squared minus 3x. And then the right hand side, of course, is a minus 4. I already put it over 1, and probably you see where this is going now. This is going to go to a cross multiplying situation. So we get negative 4x squared plus 12x equals negative 2x minus 30. So that's on the cross multiplying, right? From there, we see the quadratic. We get one side to 0. It doesn't really matter which side. I'm going to make the left-hand terms go to the right by additive inverse. So that's going to be a positive 4x squared when we do that. Going to subtract the 12x, and that's going to be minus 14x. And then we already have the minus 30 over there. And so there's our combining. We got one side to 0, and we combined our like terms. So make sure you're making sense out of that. Now, from here, I notice in terms of factoring this, they're all multiples of 2. So I'm going to do this and make sure that's making sense to you. All right. And now in terms of factoring that, you could, on this method right here, you could use AC method to factor that. If you need some help factoring that, get back to us, let us know. I'm going to say it's going to be a 2x and an x. The signs are different. I need a 3 and a 5. Okay. So if I put the 5 here, can you see what I'm thinking? That's going to give me a 10x. And if I make it a negative 10x, and then put a plus 3 in here, signs are different, right? And so that's where we end up. All right. Now, set your factors equal to 0. 2 equals 0. 2x plus 3 equals 0. And x minus 5 equals 0. This gives you a root of 5. That's acceptable. That will work. This gives you a solution of x equals negative 1.5, negative 3 halves. Okay. And of course, 2 equals 0. We reject that, rejecting that because you can't have a constant equal to 0. That doesn't make any sense. If it was a variable, if it would have been an x equals 0, we would have kept it, right? But constant equal to 0, we reject that. One last time. In the answer box on WebAssign, that's going to look like 5, comma, negative 3 divided by 2. All right. Show both answers separated by a comma. No need to show the variable. So those are the solutions to numbers 9 and 10. We hope you found them helpful. If you have more questions or want to do more examples or see more of any of these processes, please drop us a line either through the WebAssign portal or through the CU Math email account, and we'll try to put something together for you. We hope you found them helpful.